there's a rather pesky thing that can happen when you're analyzing data, and that is that you'll get outliers. So an outlier is a data point that does not fit with the rest of the data. It is either much bigger or much smaller than the rest of the data. And so when you do your typical data analysis with measures of central tendency or measures of dispersion, it can really mess with those if you have an outlier. So it's something to be aware of, something to look out for in your data sets. And in example 3, we're going to be looking at this data set 2, 2, 3, 3, 4, 4, 4, 6, and 68. The obvious outlier there is 68. 68 does not fit with the rest of the data. All the rest of the data is, one-digit numbers, and then we've got 68, which is way, way bigger than all of the other points. And so when we have something like this, it's going to mess with our data. So let's go ahead and look at this data set, look at the averages, the mean, median, mode, range, and standard deviation, and look at how it changes depending on whether or not we actually include that outlier. Because sometimes if you disregard an outlier, it can help you get a better sense of the data than if you include the outlier. So I'm going to assume that you already know how to do all of these things: mean, median, mode, range, and standard deviation. If you don't, go ahead and watch the other videos, but I've already calculated these out. We're just going to look at what happens with them. So using this data set, 68 is the outlier. It is much bigger than all of the rest of the data points. So if we calculate the average, including the outlier is on the left and not including the outlier is on the right. So you can see we get a much bigger average than if we don't include the outlier. So this outlier really skews the average and makes it so that the average really does not represent the data. So if we say that the average is the center of the data is 10.7, well, 10.7 is bigger than every single data point except for one. There's only one data point that the average is smaller than. And so the average is really not a good measure of the center if we include that outlier. If we don't include the outlier, it's a much, much better representation of the data. So 3.5 is really a much better average for these data points if we don't include that outlier. Now the median is affected a little bit, but not by much. So since the median just looks at the very center number, doesn't matter how big the numbers are, so the size, 68 being so much bigger than the other numbers, really does not have an effect on the median other than whether or not it's there. So, if we're going in from the outside, looking for the center number, it's not really affected. So, if this were 1,000 or if this were 1,000,000 or 1,000,000,000, it wouldn't change the median. So the median is just the middle number, regardless of what the actual numbers are. And so the median isn't changed very much. The only thing that happens is really we go from having an odd number of data points where we can find a center, having an even number of data points where now we've got two central numbers and we've got to average them to find the median. But the median is not really very affected by this outlier. So that's one advantage of a median over the average or the mean, because the median is less affected by outliers than the average is. Looking back in the average is very, very much affected by that outlier. Looking at the mode in this case does not change based on the outlier. So the mode is the most frequent number. We've got 3 4s. There's the most of any other number is we've got 2 2s, 2 3s, and same thing if we get rid of the outlier. There's no real change there. The range is drastically changed if we get rid of that outlier. So the range normally with the outlier is 66. So the smallest number is 2, the biggest number is 68. And so the difference between those is 66. Whereas if you get rid of the outlier, the range is much tighter, between the biggest one then being 6 and the smallest one being 2, a much smaller range. And if we calculate the standard deviation, so again for that we've got to calculate the average. Now the average is different for each of these. So on the left here we need to use 10.7 for the average. And on the right, we need to use 3.5 for the average, because the average is very different depending on whether or not you have the outlier. So be mindful of that when you're calculating standard deviation. So we take each data point again for standard deviation, and then subtract the average and square it. Do that for all the data points. I kind of ran out of room here, so I had to go down to a second line. But in any case, add all those up, divide by how many data points you have, and then take the square root. And for the data set with the outlier, we get about 20.3 for the standard deviation, and without the outlier we get about 1.2. So again, it's very much affected by the outlier, and that's because we use the mean with that, and also you can see, with this last one, 68 minus 10.7 squared, that we're going to get a pretty big number. And so that's really going to skew the standard deviation having this outlier in our data set.